This is a 3D printer, and this is an injection molding machine. Which is faster? We did this once before, and you had some questions. Let's take a closer look at time, cost, and labor in a real-world head-to-head race between injection molding and two Form 4Ls, our new large-format 3D printer. Last time we did this, a lot of you wanted to know why we only used a two-cavity mold. Well, a more complex mold would also be more expensive.
So the added cost would only make sense if you were making hundreds of thousands of parts.
And we're not making this up. The footage you're seeing now is of the exact two-cavity tooling used by our real contract manufacturer in Taiwan. You asked about post-processing. Parts made with both methods do need some work after production. Molded parts have sprues and runners removed one at a time, while resin prints are washed and cured in batches. Depending on part geometry, support material might also need to be removed. These parts were oriented so the supported surfaces aren't visible in the final assembly, so we don't need to sand down support touch points. We factored in 20 minutes per print job for job setup, washing, curing, support removal, and part inspection. You also asked about the cost. To produce 1,000 parts, ordering injection molded parts would cost about $4,000, excluding shipping and tariffs. Just getting a tool like this machined costs more than $3,000. On the other hand, 3D printing them in-house would cost under $500, including the labor, consumables, and the amortized cost of the printer hardware. We can extrapolate the cost at different volumes too. Only at production volumes over 10,000 units would injection molding take over as the cheaper option. Still skeptical? We'll link a cost per part calculator in the description so you can see for yourself. Lastly, some of you were doubtful that the printed parts would be strong enough. We printed the part in black resin, which has comparable strength and stiffness to PET. The latch actuates this way, so flexural strength is important. We also built a cycle tester to latch and unlatch the printed part several hundred times. Here's how the print looked after that test. Just some chalkiness on the wear surfaces. And let's check on our race. Form 4L wins on print speed. Plus, in addition to part production time, getting tooling cut for molding can take weeks. So in the race to 1,000 parts, 3D printing wins either by 1 hour or 6 weeks, depending on how you count. And the printed parts are up to the task. So what's stopping you from replacing short-run injection molding with 3D printing? Let us know in the comments.